POV, I'm in your house. I know you have a MacBook, so I'm going to exploit your MacBook and get a remote shell on it, and I'm not even going to do any memory corruption vulnerabilities. Bada bing, bada boom. Guys, the vulnerability today we're talking about is super interesting. It's a vulnerability that has nothing to do with memory corruption, actually. It is a state machine issue in the way that Mac OS's screen sharing was put together, and it enabled people, again, you would think like, oh, to do cybercrime, or like, oh, to like steal credentials, or like spy on people. No, they're mining Monero. Okay, the vulnerability here is really interesting because it has to do with a weird state machine problem in the Mac OS screen sharing capability. Now, in this video, there are actually two bugs. One, we have a POC for of someone actually running the bug actively. Not super exciting. This bug is actually incredible. So as I mentioned, this is not a vulnerability that Rust would have fixed. Both of these vulnerabilities are not bugs that Rust would have fixed because they're actually logic bugs. They are bugs that have to do with like the system and the logic design of the authentication for Apple screen sharing. So kind of for context, screen sharing D is a binary that runs as root, and every kind of like network daemon has this inherent issue that if there is a vulnerability before or during the authentication process, then you can get into it pre-auth, right? And so the bug we're talking about is literally in how the screen sharing daemon receives and processes the frame to begin and execute authentication, right? The process of making sure that I know who you are, you know who I am, and that you're allowed to go into my computer. In this case, this is the screen sharing process of uploading files, right? File copy protocol. This is an Apple proprietary message type 22. The bug is actually really, really interesting. So again, what you're able to do with this bug, if you're not patched, is basically arbitrarily pre-auth as root, upload and download any file on a Mac system. And how you use that to get to RCE, we'll get to in a second. But the way that it works is crazy. So I'll go into the nitty gritty here in a second, but the TLDR is that in the failure case where you send a frame that is too big to the computer, right? So if you send to the target over this protocol an authentication frame to do the authentication, right? Some kind of piece of data. If it's bigger than 32768, you're supposed to fail. You're supposed to fail out and do something else, right? Tell the rest of the system that, okay, the frame was too big. We are not supposed to go down that path. Now, while we're talking about these logic bugs in Apple devices, one thing that does have a logic issue is the length of my hair, and the barber is not going to pay for himself. So check out a message from today's sponsors. As more and more companies adopt AI, the amount of code that gets generated is extremely high, and as a result, so are the vulnerabilities. I'm super interested in ways to reduce that security debt, and that's why today's video is sponsored by Endor Labs. Endor Labs offers a variety of tools like AI static analysis security tooling and software composition analysis tools that allow you to find bugs in your code before it goes out. And recently, they just added a MCP server that you can very easily integrate into your current developer AI workflow. And right now, there's actually one version you can use for free. All you have to do is copy this line here, and it installs that with NPX and gets you going. I already have it installed, so don't worry about that. I was working on Level Labs, one of my most recent projects. We're going to skip permissions real quick. And we can first go here and do /MCP to see if we have Endor CLI tools, and we do. And we can say, hey, Claude, use Endor SAST and SCA to do a security review of our code base. It'll go through, it'll use the MCP server, it'll go off and kick an Endor scan off. You have to authenticate into Endor Labs. You can do with the URL they give you. Once you log in, you can close out of this. Now, after a few minutes, it comes back and shows me the findings that it has. Just to be clear, with the free version, this is a rule-based static analyzer. You only get the AI power static analyzer with the paid version. You may be asking, why not just use AI to do the actual research? Well, what's happening here is you're using a non-stochastic method. You're using rules to find things that could be bugs, and then you're using AI to triage those bugs. So it's actually really, really cool. And in doing this, actually, after a couple of issues I had with just Claude in general, I found a real actionable bug in a new feature. So I'm shipping this feature for the tool. It basically you can use Ghidra, and we have a little portal that you can wire Ghidra through, so we can control your Ghidra while you're doing the challenge. And the path to download that daemon that runs in the middle actually has directory traversal in it. So we haven't shipped this yet, luckily, and Endor caught it, which is pretty cool. So guys, if you're doing any kind of coding, especially AI coding, vibe coding, you need to have tools in place to prevent unsafe code from going out the door, like that directory traversal animal shift. So check out Endor at the link right here, level.tv/Endor Labs, and we'll see you in the rest of the video. Thanks for sponsoring the video, Endor. Let's keep going. But the problem is, in the failure case where you say that the length is greater, you're supposed to move the return value into the return register and then return. Okay, that is what all programs do. You return the error and you pass out. That is kind of like the general, the error shape of programs. Okay, but the problem is when you call the function net buffer read, right? Net buffer read is the function that reads the data off the network. And this, to me, this smells like somebody who was like a POSIX programmer at one point, and they like forgot to turn off the POSIX part of their brain and wrote this code. Because typically, if you go like man to receive, for example, if you read the page for receive, the function receive when you're coding in C, it takes a socket file descriptor, a buffer, and a size, and it returns the amount of values that it read, or it returns the amount of bytes that it read. Okay, in this case, they thought that netbuffer read did the same thing, but it actually has an out parameter where it just writes that to a variable, and it returns a status variable, good or bad, success, no success. And so what happens here is, sure, you may send it a frame that is larger than 32768, but that successfully got read, so net buffer read returned 0, and then you return error out of this function. Oh, by the way, error is 0, and what you're actually telling the caller of this function is that yes, 0 is success, we authenticated, right? So the bug here is literally we returned the wrong variable, and in doing that, we're able to bypass authentication completely. Like absolutely bonkers vulnerability, okay? What this allows you to do is literally arbitrary file read as root, arbitrary file write as root, and oh, by the way, you get both primitives being this idea and exploitation, a simple thing that you're allowed to do, in a single connection, right? Over one TCP connection. So the attacker chain here is like kind of amazing, right? You do the whole large blob write to get past the authentication. This returns 0 and says, yep, we're authenticated as root. Good luck. And then from there, you can deliver a variety of files, right? You can add the etc sudoers file to say that any arbitrary user is a sudoer. You can add reverse shell lines to the ZSH environment. So when a ZSH shell spawns, it does something. You're able to obviously add a authorized key to the root directory. So now you can SSH into the device as root, a variety of other things. And obviously being able to do anything like this, dropping and reading files as root gives you complete access to the machine. So absolutely beautiful. And obviously they have, POC or GTFO, the exploit to do this. Now that was only one of two different vulnerabilities in the same daemon, right? In the screen sharing D daemon. All this is again pre-auth. This is a second vulnerability that there's not a ton of detail known about, but what we do know is that it is a state machine desync, right? So, obviously a state machine is this piece, it's a coding structure that is stateful and depends on some kind of input to make state transitions to other states, right? And if the assumed state and the destination state of like the machine gets out of sync, there are potential issues that can occur in the logic it's meant to represent, right? And so this is like, again, another pre-auth vulnerability that, by the way, Rust would not have fixed, because Rust, you can write a state machine incorrectly in Rust, right? Even if you get, oh, yeah, I have fancy enum types for all of the states, and I have, very fancy like match logic to do state transitions. If you code the transitions wrong, you're gonna have the same bug. So all we know is that you can see these two packets that they send. Again, this is over Apple's proprietary like screen sharing daemon. But what they do is they do an auth type 36, and try to authenticate as a user that does not exist. Now, when the user does not exist, we actually get a challenge back, right? This is supposed to be some kind of authentication challenge. Maybe we have to sign the challenge with a private key, right? Either way, we get this fake challenge that does not exist. It is not a real vulnerability, okay? But the state now is desynced supposedly. So because we have a fake challenge, this probably puts a state machine in like waiting for resync mode. But then what we do is we do the same thing. We do a no type byte. So instead of an auth type 36, we don't provide an auth type. And then we retry to begin the authentication with the user that does exist. NQHUI is the user here. And when it sends that challenge back to us, it also says, yup, you're authenticated. So something about the state machine is inherently broken, that if we send it one auth type with a fake user and then try to auth again with no auth type, that blows up the state machine and just says, you're in, baby. Again, this is a thing where like, memory safety is kind of my whole shtick, and it's kind of like the fun part of my job. But like, it's really cool to see bugs like, well, cool for me, less cool for the developers, to see bugs like this where like literally they just returned the wrong value, and so the whole machine falls apart pretty gracefully. And what's interesting too is probably asking like, how is this not caught in testing, right? The issue with this, I mean, I know people who work at Apple. I guarantee you they have fuzzers that are hitting this protocol like a fucking, with a missile, right? Like literally with like thousands of runs a second all day, every day. The problem is a lot of the fuzzers have a default upper limit to the amount of data they will shove into a buffer, right? I think like libfuzzer, for example, the one that Clang or, LLVM comes with, I think it's like by default 4096, 1024. You have to manually specify it to go this high. And a lot of the time, it's kind of like, oh, well, we're going to have a simple, like, an n value that runs a loop, and like maybe the n underflow, so we'll catch it, right? It's very rare to pump these values up to like 65535, because then your fuzzer has to generate all that data and process it. It makes the fuzzing less effective. And so if a fuzzer had just gone above this value, you would have found it, which kind of implies that they're not doing that. Again, not a shit on them. It's just like kind of the nature of the fuzzing game. I went to DEF CON recently, right? I'm 32 years old. I went to DEF CON and Black Hat. Your boy's very tired. But there's this whole conversation about like, oh my God, if you're going to DEF CON, make sure you bring like a burner laptop and like a burner phone, because they're going to hack you, because the Wi-Fi is going to steal your password. I don't know. That shit doesn't happen anymore, right? That's not really a thing. It's not 2012 anymore. But these are actually the kinds of vulnerabilities that matter, right? The reason being, this vulnerability is only accessible if you are within network range of the person that is trying to be, if you're trying to attack, right? Like you can't just like try to screen share with me at my home. There's a variety of firewalls and NAT translations that occur between you and I. You can't get to my IP address because it's a private IP inside my home. But there are two problems with that. One, if you're at DEF CON, you're likely all on the same network. And I know the DEF CON network is highly monitored. There's probably like a guest isolation and stuff going on. But if you associate with like FBI surveillance van, the Wi-Fi, and like you and your friends are all on that, there could be a third party that's like throwing these exploits at you. And two, what makes this kind of like the nail in the coffin for this sort of bug is, again, the whole point of this article was not really about the vulnerability. It was that hackers, are exploiting these vulnerabilities to deploy Monero miners. So that implies to me that there is some large amount of computers that have their RDP, whatever the equivalent port number, VNC port for Apple, exposed to the internet. So the guy that found this bug, and if you don't follow him, I don't, apparently, sorry, my bad. Go follow him. He's the person, I guess, are the person that found these vulnerabilities. My last scan showed around 40,000 open screen sharing hosts on the internet, almost half in the US, with most being residential IP addresses, but there are many juicy hosts in American, I guess, universities, some companies, a server from BB Edit Company, etc. Party hard, never expose those services unless behind SSH. The point he's making here, there was a whole debacle that you can go through. I'm not going to go into it, but like the timeline and like the severity that Apple classified this bug with is kind of a whole different story for a different day. But he was like, no, dude, this is a really serious bug, and it's not just like local LAN. I mean, technically it is local LAN, but when you point the ass end of your network stack at the internet becomes your local LAN, right? So as a result, people are deploying, I guess, Monero miners on your laptop to do their evil bidding. So interesting bug for sure. If you like these kinds of videos, do me a favor, hit the sub button, and then go check out this other video about a similar bug. I think you will enjoy it just as much. We'll see you over there.